Hello, welcome to my talk, Machine Learning with Java, Deep Learning for J. My name is Enrique Llerena Dominguez. I'm a senior software engineer at Mimacom, and I have been working in this industry already for a couple of years, working on the finance, retail, pharma, and automotive industry. On my professional interests, I like working on software architecture, cloud computing, and artificial intelligence. On my free time, I like spending some time with my kids, watching football, and learning German, and of course, developing some nice things. Here you can see how to contact me. Here you can see my Twitter handle, my GitHub user, my email, and of course, my blog. Visit it. ienjoysoftware.dev. So here's a picture of my employer, Mimacom. This is an event that we had in Mallorca in 2019. It was a nice get together for the company, and we are hiring. So join us. So now let's get to business. What are we going to look today? We're going to look at the basics of machine learning and what deep learning for J is. We're going to look at some of the integrations with our systems that Deep Learning for J provides. And we're going to have a look at one example of image classification. We're going to look at the approach and how to solve it and some code there. So, what is machine learning? Machine learning is a study of computer algorithms that improve automatically through experience. The idea is that having a labeled data set, we can process it in such a way that we will find a mathematical function representing the relationship between data and labels. And later, we can use such mathematical function to predict the label based on pure data. So, and what about deep learning for J? So it is an open source deep learning library written for Java and Scala. So now let's look at the basics of machine learning through a story. It is about the iris classification, aka machine learning hello world. So once upon a time, there was this guy, Peter. He was a biologist, and he used to live in Canada. So there was this time when he was hiking on this Gaspe Peninsula, and some nice flowers got his attention. He thought they were beautiful. So and he realized that those flowers were new. So he gave them a name. He named them Iris virginica, Iris setosa, and Iris versicolor. So, in order to classify them, he started taking measurements of different features they had, like the petal and the sepal. And with all these measurements, he created a data set where he wrote the measurements and, of course, which kind of flower they were. And later that day, he went home to have dinner. Yeah, he was into tacos somehow, being in Canada. I mean, it's cool, right? Tacos are universal. It's a nice thing. So he told his kids, it would be really cool that someone else could classify this flower just by providing the measurements. And then his daughter, Teresa, the software engineer, who was, of course, having dinner with him, said, hey, I can automate that. Of course, she's a software engineer. He likes automating stuff, right? But first things first. Now, let's get some stuff done. So, what are the resources that she has? She has the label dataset that her father Peter created earlier that day. She knew Java. She had Maven to pull all the dependencies that she needed, and she was learning this library, Deep Learning for J. Now let's look at the problem description a little bit in a more formal manner. it is of type classification. The data set that she has 150 instances, and every instance has 4 attributes: the sepal length, sepal width, petal length, and petal width, everything in centimeters. And she has 3 clusters because there are 3 kinds of flowers: Iris setosa, Iris versicolor, and Iris virginica. So there are 2 main steps in the machine learning process, which are the training step and the prediction step. The idea is that on the training step, you will use a labeled data set. Then you will feed it into a model, into a library, sorry, not a model. You will feed it into a library, and the output will be a model. And during the prediction step, you will feed data to this model, and it will predict a label. So let's go deeper into the training steps. What are the phases, the things that we need to do here? First, we need to load the data set. After that, we will normalize the data. We will split the data set into train and test data sets. We will configure then the model. We will train the model, evaluate it, and export it. So let's look at the most valuable code. So first, to load the dataset, here you can see we are using a CSV record reader. Our data is in such format, in CSV, so that's why we're using it. And it is a class that is provided out of the box with some of the dependencies of Deeplearning4j. Then we will use this other class, record reader dataset iterator, which will yield a dataset iterator. In this case, we are loading all the data in just one pass, because they are not that much, right? They are just 150 lines, so that's why we are passing total lines. So now, after that, we will normalize the data. But what does normalize the data mean? The idea of normalization is making the data fit always in the range of 0 to 1 or -1 to 1, so that big numbers in certain features will not have a bigger effect on small numbers in other features. So here we will use the normalizer standardize. So the first thing that we need to do is feed the normalizer to get statistics about the data. And after that, we will actually transform the data using the normalizer, meaning we will normalize the data. So after that, we will split the data set into train and test. The idea is that we will use one data set to train the model and another one to evaluate it. Because if we could feed the model with data it was trained with, it will be like cheating, right? Because it knows already the answer. The idea is that we want to make sure that it behaves properly, that it has a proper performance with unknown data, with new data. So here we will use this method from the data set to create a split, test, and train object. And from there, we get the 2 different data sets. In this case, this train to test ratio is a constant, which is 65%. And the idea is that 65% of the data will be used for training and the rest for the testing. So now let's talk about configure the model. In this step, we will create a neural network. It has 3 layers. And here we will focus on the input and the output. So the idea is that the first layer, the input layer, must have the same amount of nodes as we have features. So in this case, it has 4 nodes because we have 4 features: sepal length and sepal width, petal length and petal width. And then the output layer must have 3 nodes because we have 3 different classes or types of the flowers, which are the Iris setosa, Iris versicolor, and Iris virginica. So after that, we will train the model. So we will get the configuration that we created in the last step, and we will create a multi-layer network with such configuration. We will initialize it. We will set some listeners to get some scores during the training, during the iterations, and then we will fit the model. In this case, it is going to be 1,000 times. Why 1,000 times? Well, it was a number found empirically. So the idea is that I made a test with 1,500 iterations, and the number were not better. The numbers were not better, and using 500 iterations, the numbers were indeed worse. The performance metric, I mean, with this. So I ended up using 1,000 iterations. So now on the evaluate step, here we will take advantage of this evaluation class, which is also provided out of the box of Deeplearning4j. We just need to provide the data set, and it will return something like this kind of evaluation metrics, where you can see the accuracy, precision, recall, F1 score, and the confusion matrix. I will not go deeper into what all these things means, but they're important, so I recommend you to have a look at them. So after that, we will export the model. And for this, we will just export the model to a file. So we need to create a file wherever we want to store this. And one important thing is that we also need to store a normalizer, because later in the next step, we will need it to normalize the data the same way we used to normalize the training data set. So here we are done with this step. Now what we have is a stored trained model, and we have a normalizer. So now let's look at the prediction step. First, we need to load the model that we stored in the last step. Then we need to format the data, normalize it, feed it to the model, and get a label. Let's look at the most valuable code of this step. So here we load the model from the file that we used earlier to store it, and we use and we do the same thing for the normalizer, right? So now we have both things in memory. After that, we format the data. We need to transform it into an ND array, and so we change this iris. It is just a pojo that I did as a domain object. So we transform it to an ND array, and hold the data in this data buffer that is within the ND array. So in order to normalize the data that we just loaded, we just need to transform it using the normalizer, and then we will feed it into the model to get a result. But the model returns us a distribution of probabilities. So we need to find which, it's an array. So we need to find which element of the array has a higher value, meaning it has the highest probabilities of being predicted. So once we get the max index, we can map this to our known labels, and this way we can map the index to a label. So this is, as you saw, this is normal, regular Java code, which we can grab into a, for example, a REST API. Let's say the flower classification API. So this way, everyone could provide some numbers with the length and width of the sepal and the petal, and this API will return which kind of flower is this. So now we can say that Peter is happy because now his friends can classify these flowers just by calling the flower classification API with the measurements. So, what did we learn with this small story? There are two main steps in machine learning: training and prediction. The input of the training one, of the training step, I mean, is the labeled data set, and the output is a trained model. In the prediction, uh, we need two things that will be the input: the trained model, sorry, and the unlabeled data. The idea is that we will provide the data to the model, and it will return a prediction, which is also the output of this step. And in this case, the prediction is classification. And we also saw how to use Deeplearning4j to train a model, export it, load it, and perform a prediction. So now let's have a look at the different approaches that exist there in machine learning. Uh, you have supervised, unsupervised, and reinforcement learning. Into the supervised, you have um, the idea is that you have a data set containing features and labels, which is fed into a machine learning algorithm to find rules that map the data to the labels. And there are these two basic subtypes, which are classification, where the features are mapped to a label or a class. And on the regression, the idea is that the features are mapped to a number. Then on the unsupervised, you have a data set without labels, which are fed into a machine learning algorithm to find relationships amongst the data, like hidden patterns, or to find a structure. And then on the reinforcement learning, the idea is that you have an agent that interacts with an environment using a set of actions looking to maximize our reward. And machine learning for J, deep learning for J, sorry, supports all of them. Now, let's look at the different algorithms that exist in machine learning. There are quite a few. You have decision trees, super vector machines, linear regression, and so on and so forth, and also neural networks. And in this case, Deeplearning4j just supports neural networks. So now let's have a quick look at the integrations that Deeplearning4j provide, the integrations with other systems. If you want to do distributed training, you can use Apache Spark and Apache Hadoop. If you want to use or to do parallel training, you can use NVIDIA CUDA, which is, in this case, is really nice because you just need to change your dependencies, and out of the box, you will be able to perform your training in such a graphic card. And if you want, you can also import models which were done in Keras. And I find this integration particularly interesting, so I will dive a little bit deeper into this one. But first of all, I need to say what Keras is. It is an open source neural network library written in Python, and it runs on top of, for example, TensorFlow, Microsoft Cognitive Toolkit, R, Theano, or PlayML, amongst others. So we saw earlier that there are two main steps, the training step and the prediction step. And in our example earlier in our story, we saw that they are actually decoupled in time because we stored the trained model in the file system, and then that means that both steps are decoupled in time. Also, in our example, in our story, we saw that both steps were performed with Java. So the idea is that this integration between Deeplearning4j and Keras provide flexibility. But why? Because now you can, for example, have your training step done in Python, and your prediction step, you can have it done in Java, which then enable enables you to integrate people with different technical profiles. For example, you could have uh, your data scientist, which is more comfortable working with Python, creating your models, and then exporting them if they were created using Keras, and then you can have your software engineer, which is more comfortable using Java, importing such model and deploying it into production. And another advantage of this is that it opens the door to more pre-trained models that you can use. So now let's go to our image classification example. The idea here is that we will use the model SU of Deeplearning4j, and we will use OpenCV to do some image manipulation. Deeplearning4j provides model SU with different models that are already configured. In this case, we will use YOLO 2. YOLO stands for you only look once, and this is an example of what it can do. You can identify different kinds of objects on an image. It is limited. You have just so much available labels, but we are lucky because these are exactly the kind of things that we want to detect in images. So, what are the steps for solving this problem? First, we will need to load the model from the SU. We will load the image. We will pre-process the image. We will feed the image to the model, to YOLO, and then we will get the detected objects and annotate the original image. Let's look at the most valuable code. That's it. This is all we need to do. So here you can see how we load the model from the SU with this YOLO2 builder, and we create this pre-trained computation graph. After that, we load the image from the disk, and then we transform it to an ND array. Then we need to resize the image and to change the format so that we match the parameters required by YOLO2. And then we need to scale the image, meaning normalize the pixels so they can be on the range from 0 to 1. After that, we feed the image to the model, and it will return a list of detected objects, which we will later use to annotate the image. So it's really simple. And this is an example. Here you can see that it detected a person and a motorbike on the very front of the image. Also, it detected another person and a motorbike. It missed those two behind it, but I mean, it's all right. It's tough to detect them. Here it detected a couple of small bears. It's nice. This other example I like because it detected properly a bird, but it's just the half of the bird. So I find it interesting. Now it detects a person wearing a backpack. It's cool, nice. And here it is starting to get weird because it properly detects a couple of cars there, and it detects a person, but it says that the tennis shoes are a skateboard, which is kinda weird. And then here we can see one bear, but it detects that there are two bears. Alrighty. And this is gonna be my favorite one. There we can see a bear, yeah, in a no so good image, but still we see a bear, and it detects it as an elephant. So what did we learn from this story? Well, test a lot, just to make sure that YOLO is actually detecting the things that you are expecting. So, what did we learn? We saw some basics of machine learning and some of the basics of Deeplearning4j. We saw some of the integrations that Deeplearning4j provides, and we saw this image classification example. If you scan this QR code, you will get all the relevant links to the repositories uh, holding the code for these examples and some more examples. And I would love to use, I would love to find out, to ask you, how do you want to use deep learning for J? Thank you very much. You can find some blog posts about this talk at my blog, ienjoysoftware.dev.
Hello, yeah. So thank you very much for having a look at the presentation. Uh, Please visit the blog at ienjoysoftware.dev. There you will be able to find a link to the code and uh, the link to the presentation and so on and so forth. So the first question already came, and I will read it. It says, can I load a model with Deeplearning4j, which was trained with another machine learning framework like Python's TensorFlow? And the answer will be yes, if it was done also with Keras, right? Because that's the interface that is amongst the languages. So yeah. Then the second question that I got is what other models are available in the model zoo? Well, there are quite a few. So, for example, well, there are a couple for image processing. There is another one, FaceNet, for example, which you can use for face recognition. You can also use Tiny YOLO, which is a smaller version of YOLO. It recognizes less less objects, let's say. So yeah, you can have a look at it on the website. And then the next question that I got is, are there any examples to do sentiment analysis in text? So yeah, there are a couple. One of them is in the examples of on the samples of Deeplearning4j itself, and there is another one there at my GitHub repo, and yeah, you can have a look at it, at the code, and so on and so forth. So yeah, and looks like there are no questions anymore. So great. Thank you very much for looking at it. And yeah, okay. I am telling. Okay, I need to wait a little bit. There's another question. Does the model depend on the order of data? I don't get that question. So when you want to do classification, when you want to feed the data to the model to get a classification, for example, then you need to provide the data in the right order. Otherwise, I mean, that's the only thing that I can think of that is important on the order.